So, how to make a game like Grow a Garden on Roblox? Well, its most iconic feature undoubtedly must be its plot system, assigning plots to new players and cleaning them up once they leave, and of course being able to plant and harvest seeds. So in order to create a plot system like in Grow a Garden, first let's add a parent object, for instance a folder for the plots that will be. If you like, you can rename it, and then each plot will be represented as another folder. You can also go with a model, but those are typically used rather for moving objects, and give it a unique name, for instance one. We can go over all of them via code later down the line and check which ones are still available. Insert a part as for the ground. Rescale the way you like it. If you prefer to have this static, you can also go with one from the toolbox. I think you can just enter a start block here, or a start part perhaps. Go with a brick color you like, probably green. And once we've scaled it up to a appropriate size, we also need to make sure to anchor it, which for this toolbox object was enabled by default, so it doesn't move around when colliding with it. Then with my complete Grow a Garden like template you can find in the description, I was also adding those fences from the toolbox. And in its demo you will also find out I also added this billboard UI featuring the player icon. But for now let's keep it simple and just go with a sign like this. So let's look one up in the toolbox, for instance this one. And then when it comes to the logical structure, we will have to, it should be an attribute, if you will, of the plot, be subordinate. Let's parent it here as well. And since we will have to go through this hierarchy in the code in a minute, let's give all the parts we need, for instance this one, a unique name. Now let's quickly check whether we need to anchor any of its parts in case it falls apart. It does, so we need to go through all of those and check and see if there's anything unanchored, which we can fix like this. By the way, you can also switch to a test here, so it's a little easier. You don't have to go this quick route in case your one location is somewhere else, like with mine. So that looks way better now. And since we will have to access the floor later down the line as well, let's make sure to also rename it. And then once you're done making changes to it, you can basically just duplicate it using Ctrl and D, however often you like so. You can also select all of those, holding Shift and putting another, column to the other side. Maybe space them out a little more. And again, give all of them unique names, for instance 2, 3 and so on. Alright, so now we're ready to add our first script when it comes to this system. In my specific case, you can still find the restocking shop script from the first episode of this series. So let's add another script here, for instance plot. And now whenever a player joins, we need to reserve a plot for them. So first we need to detect it, like this, get access to the respective service, and connect to this event. And for now I just added print it, to test it. Let's see, there you go. Of course it's still loading locally, but that shouldn't matter. It might actually be a benefit because this way there won't be any visible delay on the player end. Okay, so now our task is basically to go through all of those plots, and as soon as we find an empty one, reserve it for the player. So get access to the plots like this. Depends on your name again, it needs to match here. Go through all of them like so, and then we essentially need to come up with a way to tell if it's been allocated yet. For instance, we could add a new attribute down here whenever it is assigned to a player. So it will be empty like this in case it isn't. And then this is just an example, but we could do it like this whenever, the other way around actually. If there's a player assigned to it yet, we check the next one right away without executing, without running the code we put below here. Now we need to reserve it. For instance, we could create a new function up here, so a dedicated code snippet if you will. So it is clean, but we can also easily call it from various points inside our script and call it here whenever we encountered an empty one. Pass those values in the plot and player, so those match up. The names don't need to be equal, but the order will have to be. To go with that approach I just outlined, adding the player as an attribute to the plot, so we can tell whether it's been assigned or not yet. Like so, just call the attribute player and save the player's name there. Let's see if it works. So perhaps the first one. Yeah, there you go. So now it says player, and it has my name right next to it. If we want to make this kind of bi-directional, we can also do it vice versa and add an attribute to the player stating the plot it was assigned to. So this time around, Again, I will be skipping this kind of billboard GUI here and just go with the sign so it's as easy as possible. And yeah, you can also find this as a modular piece. So what hierarchy did we end up using? You can see it here. So make sure it follows the same hierarchy. In my case, stat sign here, front part here, service GUI text label, and then set its text to player.name or player.name's plot or whatever. You can also change its default value the way you would normally do so. And you can also add teleport buttons or just move the player to its respective plot at the start of the game automatically. But first let's see whether or not it works. There you go. And as soon as the player leaves, we also need to make sure to essentially clean it up again. So, you know, whenever someone new joins the game, there are empty plots available again. So we need to do it like this time around. So connect to the removing event, get access to the respective plot. So the one sitting inside our or below our plots folder with having this the name we saved below our player all the way down in the attributes. Set in the player stat to nil. So this won't fail. And then if you like, you can set the signs text back to text or empty plot or whatever you prefer. Let's check it out real quick and go with server and clients this time. Perhaps set the player amount to 1 so we can leave with the player without the server shutting down. Plot getting assigned correctly, or almost, but we'll talk about that in a minute. And you know, it says player 1 because it's a test player. And whenever I leave, let's check out the server. It says text again. But now the reason why all of them say player, so all of them got assigned essentially, is because there's no reason why the assignment process would stop, because we just go through all of them, and as long as they don't have the player attribute set, we assign it. So we will also have to break after the first one, so it doesn't apply to all of them, only as long as there's an empty one. Let's have another look, like this. So this one goes on to say text now, i.e. it remains unassigned and only this one is occupied. But how can we allow players to actually plant objects on their plot? Well, first we need to be able to detect mouse clicks and what exact location of their plot's floor part was actually clicked. And since this has to do with input, we need to handle this on the local end, so on the player's device, if you will. So for instance, here in starter character script, which is whose scripts are run every time the character respawns, as opposed to just starter player script. We can add a local script here, and this is where we can essentially handle the input now. But since you most likely will want to add multiple types of hovers, you most likely want to add a new tool to starter pack. For instance, let's start with an apple seed now. And it's quite easy to add new seeds or new plants in general to my framework. I think we have, let's see what we got there. Here we got carrots, apples and coconuts there. But for now let's just go with one. But then you would probably like to do something like setting an attribute such as let's say plant ID to the respective tool. And for now let's disable requires handle, unless you would like to add a visible object to the player's hand right away. And now you can see the item, like the tool, being added here correctly to the built-in hotbar, I think it's called, or tool belt. And the reason why we did this is not only because it makes it easy to switch between seeds or tools like the remove tool, but also because it comes with a built-in activated event we can use. So let's get access to the player character like this. If it's still spawning in, we just wait until it's done. And then whenever we equip a tool, it is automatically moved below the player character. You can also test this. So this is my player character. As soon as I select this, it pops up right here. So let's add a code snippet to detect whenever this happens. So whenever a new object is added as a child to the player character, like we just saw, we check whether it's a tool, and in case you plan to have other tools, such as the remove tool, you likely also want to make sure to filter out those, which for instance you could do by making sure it has a certain attribute, like a plant ID, which you can add like this. I was just setting it to 1 now, but I don't think I will be using it. So here's the event we can connect to in order to detect once the player clicks the left mouse button or taps onto the screen on mobile. Let's just print an empty message to see whether it works. So nothing happening now, but as soon as I select it, you can see the empty message popping up in the console with this default info like the timestamp. So this slightly chunky code snippet here allows us to essentially shoot an invisible ray, like a laser, from the camera toward wherever we clicked, and in order to detect where it intersects, which will be the planned position. But we still need to get access to the mouse. We'll talk about this in a minute. We can get access to the mouse like this, and get access to the local player's plot like this. The reason it's not best practice for sure, but I think it will keep things a little easier for you. We just wait to make sure the server has especially here for testing inside this studio environment, to make sure the server has enough time to assign a plot for us. And this is where those settings here come into play. We set it to a whitelist or include mode to prevent it from intersecting with other objects, like other than the local player's plot's floor. So we can plant it, I don't know, on the roof of the shop or on other players' plots. So first let's see if we get any result in the first place. Nothing happening here. Nothing happening here or over there either. And also nothing happening here. Well, let's figure out why. Oh, never mind, not sure, maybe I just wasn't saving or something. So it says no, essentially an empty object, like a non-existing one, whenever I click somewhere other than my local player's plot. But here it gives me this data structure. However, we won't need to fully understand it. We just need to know it holds the position. So in case it isn't no, so we hit something valid, which we can verify like this. We want to extract its position and have a look at it so we can figure out whether it works or not. So nothing popping up, but here we get a position. However, since this one is the global position, we're going to save this persistently, and next time you join the game, or any of your players join your game, and they get assigned to a different plot like this one, their plants will still spawn over here, since it is the absolute position. So we need to get the relative one, preferably, like for instance, from the floor. I don't think I will be going into persistent data saving for this tutorial. Maybe next time, but I hope this will still save you a lot of headache later down the line. But this is how you can, you need to get access to the floor again, like up here. Like you did up here, you can also do it via a single variable at the start. And this will be the interesting function in order to convert it to a local position relative to the floor. If we were to print this again, or rather just the position aspect of it, you can tell this looks much more like a local position now, because the values are way smaller, and also the y-coordinate almost doesn't change, aside from some, I guess, mathematical uncertainty you always have. But now if we were to plant new seeds here, other players wouldn't be able to see it, and also wouldn't be secure, and this is why the server exists, to provide a single point of truth when it comes to the data, and also to keep it safe, because it will be a physical machine somewhere, I guess in one of Roblox's data centers. We now need to ask the server whether it allows us to spawn a plant in this position. The way we can do this is by using emote events, which is just a signal like either the client or the server can trigger, and the other party can listen to it and react accordingly without returning data directly. So that's essentially the difference between remote functions and remote events. For instance, plant object, get access to it like this. Remote storage, the remotes folder, where actually I think this is the way I did it in my the modular system for this one in the description, as well as the framework. I think here I just put it directly into replicated storage. So we do it like this then, and give it whatever name. And now below here we can trigger it in order to have the server react accordingly. If you like, you can transmit the tool, so the server can inspect its plant ID and whether the amount the player holds is still sufficient, which for instance you could do via another attribute, which we won't be diving in this step, but we might be in the future, as always. And also pass over the relative C frame. And now we can detect the signal being fired from the client in here, like inside the script, server script. We need to get access to the remote event the same way we did on the client and connect to it, for instance, down here. Make sure to use the player as the first argument, even though we don't pass it here because it is passed automatically when firing, client to server events. Let's have a look, for instance, by printing the tool's plant ID, like so. There you go. So 1 appears to be correct, and this time you can see it saying server here, and it's also green on the left, meaning the server is listening to the client request correctly. You can also play a sound here like I did in my premium framework if you like. But now let's dive into the toolbox once more, so we can find a nice tree for the apple plant, for instance. I think this one here, by Kalen, I guess, is the exact one I was using for my complete Grow Garden-like framework as well. So this one will be interesting if you want to introduce plants that can bear fruit recurringly like this. But honestly, after reconsidering it, I think it might be better for at least this episode to focus on things we can plant once, like the carrots. So I guess I would rename this to carrot. Let's see what we can find here. Oh yeah, I think this one, the cobalt nest, was the one I ended up using too. Sure, everything is anchored again, like so. Now we need to store it somewhere where we don't have to bother in this physical space, for instance inside replicated storage. Now whenever we receive our plant request, so we can get access to the player plot again and its respective floor, you will see why in a minute. But then the interesting part is we clone the carrot, like we duplicate it in here, reparent it to the workspace where it can become visible, and move it to the position we clicked. But since we transmit it as a relative position, which will help you save it persistently later down the line, we also need to convert it into a global one again, which you can do like this. We just apply those two onto another, essentially, by multiplying. Not to bother you with, I think linear algebra is called too much here. One of those many mathematical errors out there. Let's give it a try real quick. There you have it. But of course you will might also want to perform some additional security checks here. For instance, checking whether it is inside the correct boundary box, whether the player even has enough carrot seeds in their inventory, and so on. It would likely also be better, like structurally, to have the object somewhere below the plot, so we can tell what plot it belongs to and what player does. For instance, we could just add a folder to each of our plots, saying, I don't know, plants. You can just, copy it, select all of those, and then paste it using Ctrl, Shift, and V. One of the most, valuable information I ever got in my life, not gonna lie. So then you could essentially also do it like this. Quick test again, just to make sure. So yeah, at the correct spot inside the hierarchy. How can we harvest those now? Right before adding the growing process? Well, somewhere inside the carrot blueprint. For instance, if we make this the primary part, below here, we can add a proximity prompt, being those, red boxes showing up like saying press E in order to interact, and change its action text to harvest, or whatever preference you might have. In case it doesn't show up correctly, you might also want to disable requires line of sight. Sometimes if there is too much geometry around it, it won't show up this way. So now whenever we spawn in or plant a carrot, we need to get access to this proximity prompt in order to connect to its triggered event, so we can tell whenever the user triggered it. We can do it right in here. We can connect to it like this, as long as we have the primary part set. Access its proximity prompt, connect to its triggered event. For security purposes, you might also want to check which player attempts to harvest the thing anyway, so you don't end up creating steal a garden or whatever, grow a thief. So in case they're not the same, cancel right away, so this subsequent code isn't even run. So let's give it another test. Alright, so this tells us we're being notified about the harvest request correctly, and it's the correct player attempting to harvest it. Of course, if you like, you can also disable those proximity prompts, or not even add them to other players aside from the plot's owner. But let's keep it simple for now. And what we want to do is essentially just destroying the plant again, like the physical object, and then depending on how you are going to set up your entire game, you can, for instance, create a new tool like carrot harvest or whatever, and grant it here. You can also another one of those tools inside the player's backpack rather are being created. Yeah, like this. Pretty much, but since this episode will be about the plot system itself, I don't really want to dilute the point too much here, or dilute the focus, I should say. This is also how you can do it. How you can do it if you want to add a remove tool, like a little shovel or so, the way I did in my framework, so you can remove plants, apple trees, or whatever recurring harvests you have to make some room for new ones. But now how do we implement the growth process, where the harvest is essentially growing every second or so? Well, all the way down here we can add some code inside this to run every second or whatever interval you prefer. If you would like to add some code, like I was showing in my previous tutorial, you can also encapsulate this into task spawn, like so it runs in parallel, and you can add code here. But for the sake of readability, we'll do it like this now. So we can perform an action for all of the plots. You can also use collection system in case you already know how it works. So you can iterate over the plants directly. Otherwise, you can do it like this. So perform an action for every plot, and then do the same thing for every plant. And this way we can update them now. If you want to do it extremely smooth and you want to save on internet bandwidth, you can also do the visual part of it on all of the clients instead of doing this directly on the server. As they say, the server is actually supposed to be the brain, like for verification and so on, whereas the clients are supposed to be the muscle, they say, because all of this requires a network synchronization, and the sending data across the internet is essentially, I think, around 1 million times slower, so in the millisecond area, as opposed to nanoseconds on the client. But I still decided to do it like this now, so we have a simple point to start your journey. But first of all, let's see if this works. So no plants so far, it seems. What happens as soon as we plant one? There we go. Updating every second. Oh, and by the way, if you would like to limit the maximum plant distance further, you can, for instance, do it here, or also calculate the difference somewhere here and check whether it is at most whatever value, like 10 or so. But now let's add a dedicated update function, so it's a little more clean, like so, and call it down here. And now we'll need to find a way to rescale the plant so it actually ends up growing. But the problem is, most objects are composed of a lot of single parts, and also if you just increase their size, they will lose their relative position. For instance, with an apple tree, if the apple is at the very edge of the leaves, and you increase like both the apple as well as the leaf object in size, the apple itself might still be hidden somewhere inside the leaves. So for this, there's one slightly larger function I would just copy in here, like paste in here if you don't mind, that you can copy then, being this one to be precise. This way it will just be easier. You know, it originates from one of my, let's say, standard functions I always use. So this is essentially the model, in our case the carrot, and a scale factor, like between 0, like not including 0, and whatever high number. So we keep track of its pivot, so we can restore its relative position, like its offset, which we do all the way down here. And then we increase the scale across all axes, because just changing this here won't work at runtime. Apply this new size object, restore the relative positions, and this is essentially an edge case we might be going over another time. But as you can tell, it refers to just another of those instance objects. Oh, and don't forget to add this argument. So now for testing, we can, for instance, make our carrot have twice the size, just to see whether this even works or not. So it doesn't seem so, obviously, and I think I know why. Right, it would be a bit unfortunate if we scale this down to 0.5 or 0 or so, and then whenever we use 2 for the scale next time, you know, it would still be 0 because 2 times 0 is still 0. So we need to keep track of its original size so we can use it as a baseline. And to make this simple, this is kind of my standard function I use for that purpose. Go over those base parts or special measures, whatever your toolbox asset uses, and register all of this by setting the attribute the same way we did with the plant ID, for instance, earlier in this video, or the player attribute below the plots and so on. So when planting an object, following the respective remote event, actually, we record the original size here. What about now? Way better. You know, the 1 second delay being because of the update loop. If you want them to have an offset, you can just, you know, change the object's composition directly here inside Studio, or going with another primary part. But now the size should obviously depend on for instance, the number of seconds we are currently waiting. So when planning them, they should start at close to 0, and then, for instance, if 2 is the harvest time, depending on how far we are inside this 2 seconds window, we scale it up to 1, so its original size. So we kind of need to memorize the plant time, or at least whenever planting, like in here, we need to save the target time. So for instance, the current time plus 2 seconds, or whatever you want to go with. You can also make this defer for all of your plant types, like I did in my premium framework you can find on Roblox, where I think I'm using separate values, like for the coconut and so on. You can easily change in the settings there, and also the fruits themselves, because, you know, those coconuts and apples have a recurrent fruits people can harvest, like in the original, like Grow Garden, we use as inspiration here. So what better place to store the plant time is there than to go with an attribute right below the copy. All the way down here, we store the, I think it's by default it uses the seconds since January 1st, 1990 or so. So for instance, call this plant time. If you're adding persistent saving to it, you can also, you know, when saving, can just add an entry for all of those plants, and then have the position, I guess the plant ID, as well as the plant time as values inside this table right before writing it to data store. So the plant time is just the current time, the way we set this up. You can also use os.time here. I think inside the Roblox environment doesn't really make a difference. And at the start, we want to scale it down to a very, very small value, perhaps 0.01. And of course we don't really need to do this. We could also, you know, it takes 10 seconds. After the first second it should be 1/10 when it comes to the factor, but still I think, you know, then we would have to, in the worst case, we would have to wait around 1 second for it to update, if you go with 1 second here. So preferably we just set it right away while we're still at it. And then inside our update plant function, you know, the very thing we call repeatedly, we calculate the end time. So let's say the plant time plus 5 seconds. Again, if you want to make this depend on the type of plant, like in my template, feel free to do so, or you go with any other value. And then we want to calculate the progress, like the difference you can see here. But I also divide by the total time, so 5 seconds. So it is the relative progress. So instead of, I don't know, we're 4 seconds in, we get 0.8, so we're 80% in essentially. But let's say the user doesn't actually harvest it, so it's been, I don't know, one minute. It would be I guess 10 times the size, or not really, but at least a multiple of 1 of the size. So you might also want to limit it to 1 on the upside and 0 on the downside, which you can do like so. And then the way I set up this progress value, you can just put it into the scale model function, like so, and remove this test thingy up here. If you like, instead of calculating this again whenever attempting to harvest, you can also use the update function to, once it's reached 100%, save another value, but then you need to make sure to also save it persistently. For instance, create a new completed attribute for the respective plant, just being equal to true. But first of all, let's find out where the scale process works in the first place. So it starts very small apparently, but from what it looks like, it doesn't really scale up. Let's figure out why. Plant time should be correct, since we don't really update it. But let's quickly find out what the end time, as well as the progress value is. So 0 apparently. So I guess then it must be something around like about this formula here. Does it work if I use tick here again? Yes, it does perfectly. Now it works. So yeah, there was something going on with the difference between os.tick and .time and tick. Maybe it was as soon as you publish it, it doesn't make a difference anymore. Maybe it was like this. I don't really recall. Let's see. So apparently this is what Gemini says. So one of those appears to be deprecated, and the other one appears to be useless. Same as always, I guess. And also I wanted to show you this real quick, in case you're interested. Let's also test where the setting this completed attribute works yet. So not set, and there it is set now. So there's one final thing. Like in order to prevent the players from harvesting their plans prematurely, we can check whether this attribute has been set yet here. So in case it hasn't been set yet, we cancel again, meaning all subsequent code won't even be run. Can't harvest, I can't harvest, and what happens now? There you go, I can harvest. I thought I'd have to starve to death for a second. However, it's been quite some time since we last checked what happens once a player leaves, and as you might have thought already, we don't even handle those plans yet. I mean, it's not that difficult, but instead of just clearing those flags and resetting the sign again, we also need to pretty much do what we do here. Despawn all the plans the plot has to offer. As always, perform an action for all of the plans. Make sure to use the correct name here, and the action being destroying the plant. So let's dare to have another look. So plants growing here. What happens once I leave? They vanish. And if we really want to make sure, we can also add a new player, like to the same server instance, so without restarting. So it says player 2 now, as it's this new test player's name, and it's, as you can see, the same plot has been assigned, which is a good sign because it means it was actually considered empty by the server, because we removed the player flag, and I can apparently use it the same way and only harvest as soon as the maturity process has been completed. Awesome. Future things you might want to add might be this remove tool, for instance, or a grow all sign, which, as long as you know how to use developer product, should be fairly easy now. But again, if you need help with any of this, in case things don't work, just feel free to reach out. I think next time we will be having a look at how to add a second store like this one, in order where you can sell your harvest. Yeah, like this. Anyway, I'll see you then, take care.